Hey guys, okay, so this is the notes for the discriminant, okay? So as you learned in the video last night, the discriminant is going to be this little chunk right here that is under the square root symbol in something called the quadratic formula. So on your reference sheet for the A1 Regents, there is a little spot called the quadratic formula, and it's located right down here. And the quadratic formula is a very handy formula that we're going to work with a lot in this unit. And it basically tells you what the solutions are to any quadratic written in standard form. So underneath the square root, there's this little chunk called b squared minus 4ac. If you're on the exam and you forget what the discriminant is, you can just remember that he's located right here. He is the discriminant. And the discriminant is a very special word or thing that tells us about the number and nature of a quadratic's roots. So let's review what roots are again, okay? Roots of a quadratic are going to be where the function crosses the x-axis, okay? And they are written as x equals 2 and x equals negative 2, something like that, right? The quadratic formula, this whole thing right here, will tell you these special numbers if you have a quadratic written in standard form. So that's pretty cool, right? Well, if you calculated the discriminant, it would tell you how many of these you would get, because remember, sometimes you can have a bounce, in which case you would just have one root, or you could have a quadratic that's been shifted all the way up and he has no roots, right? So the discriminant is going to tell you how many roots you can have, 2, 1, or 0, and whether they are nice numbers or decimals, okay? And how does the discriminant do this? Well, the discriminant tells us with its sign. So if the discriminant is, let's abbreviate the discriminant moving forward as the disc because it's a long word to write. So if the discriminant is negative, you're writing this at the top of your paper. If the discriminant is negative, you have a quadratic that has no roots. It does not cross the x-axis. If the discriminant is 0, you have a quadratic that hits the x-axis just one time. And then if you have a discriminant that's positive, you have a quadratic that hits the x-axis 2 times. And then depending on whether that's a nice number or not, it could tell you about what kind of roots you've got, okay? So if you've got a perfect square under that square root symbol, you have something called rational or nice number roots. If you have a non-perfect square, you're going to have irrational or decimal roots. Okay, so let's go ahead and work with this a little bit, okay? So we're going to identify A, B, and C from the equations below. Why are we identifying A, B, and C? Well, look at this formula right here. What are the inputs? Well, I'm scanning through and I see a B, I see an A, and I see a C. 2 and 4 are just constants. They're always going to be 2 and they're always going to be 4. So I would need to be able to identify the A, B, and C that comes from the standard form of a quadratic in order to even use this formula at all. So let's review that A is going to be the coefficient of the x squared, B is the coefficient of x, and C is the constant or the caboose. So if you have a quadratic written in standard form, it's super easy to identify what goes where. So first on question number 1, let's see if he is written in standard form. He is. I have the powers in descending order with the constant as the caboose. So A is the coefficient of x squared, B is the coefficient of x, and C is the constant caboose. Let's look at question number 2. Is he written in standard form? He is not. The constant needs to be moved over so that way he's with all of his friends and we can rewrite this as f of x equals. Now everything's all together. We're in standard form. It's easy to find A, B, and C. A is the coefficient of x squared, B is the coefficient of x, C is the constant caboose. Notice how the sign goes with the term. Let's look at question number 3. Is he in standard form? No, he is not. Instead of moving the moving the 3x squared to be over with the 6x and the 5, I always would like to try to keep a positive leading coefficient, so I'm instead going to move these pieces over. It just makes it easier to work with in case we ever have to factor or anything like that. So now we have our quadratic written in standard form. I can clearly identify A, B, and C. A is 3, B is -6, and C is 5, not C like I just wrote. C is 5. So now that we've practiced identifying A, B, and C, let's put them into the discriminant and calculate a discriminant. In order to calculate the discriminant, this is how I want you to set it up every single time. I want you to write A equals, B equals, and C equals, and then I want you to write the formula for the discriminant. Notice how we just take the b squared minus 4ac. We don't take the square root symbol, okay? B squared minus 4ac. This helps remind you where everything goes. A is the coefficient of x squared. There's nothing written, so it's a 1. -5 is the coefficient of x, which is b, and c is the constant. So let's plug these into the formula for the discriminant and calculate the discriminant. We'd have 25 minus 8, and that's going to give me 27. Okay? Sorry, no, 25 minus 8. That's going to give me 17. Okay, so now let's try to see how many roots would there be. Is 17 a perfect square? It's not. So we would say that there are 2 roots because the discriminant is positive, and then the type of roots will be irrational because 17 is not a perfect square. Okay? Let's do question number 5. Question number 5. A is 2, B is -12, oops, and C is, oh no, he's not in standard form. Let's go ahead and put him in standard form first, okay? Now I can fully identify where everything is and where everything goes. A is 2, B is -12, and C is 18. Let's plug this into the discriminant. Now before it was kind of easy to do that one in our head. Let's type this one in our calculator. And I want you to really practice making sure that you type this in correctly with parentheses. Negative numbers always go in parentheses. Okay? Use your parentheses. Oh my goodness, what did we get? We got a discriminant of 0. Now when the discriminant equals 0, there is only one root, and they are rational. Okay. Let's look at 6. He is not in standard form. Let's move this over. Let's move this over. A is 3, B is -6, C is 5. Let's plug these into the formula for the discriminant, b squared minus 4ac. And then let's type this into our calculator. I have -6 squared minus 4 times 3 times 5. All right, I got -24. So if my discriminant is negative, that tells me that there are no real roots. Come on, let's change to red for negative. All right. There are 0 roots, and they don't exist. You can just write NA. There are no roots. We can't classify them as rational or irrational. They don't exist. So let's simplify the following radicals. 9 and 99. Let's type this into our graph page. 99 divided by x. Control T. I'm going to scroll till I find a perfect square. 9! 11 and 9. The perfect square goes first. The answer is 3 radical 11. What about negative 60? Let's do that one. Negative 60. I don't need the negative. I'm going to scroll till I find a perfect square. 4. 15 and 4. There's a negative out front. Careful. That's my answer. All right, let's look at the practice that we have to do today. So it says that we need to take the function or equation, calculate the discriminant, say how many roots it has, say whether they're rational or irrational, and then circle one, and then sketch a picture of the parabola. Then factor if it's factorable. Okay, this is sideways for me, which is very irritating. Let's see if I can fill this out sideways maybe. Okay. Okay, so first, the one that I'm filling out is x squared minus 4. I'm going to calculate the discriminant. Alright, so I've got coefficient of 1, there is no b term, c is negative 4. So I get 0 squared minus 4 times 1 times negative 4. Negative times a negative is a positive. My discriminant is positive 16. How many roots are there? There are 2 roots because it's positive. They are rational because 16 is a perfect square. And my parabola would look something like this. X equals 4, x equals negative 4. Is this factorable? It sure is. I would factor this to x plus 4, x minus 4 because this is a dots. All right, next I've got x squared minus 5x plus 6. A, B, C, set up your discriminant. A is 1, B is negative 5, C is 6. 6 times 4 is 24, so out of 25 minus 24. And this would end up being 1, which is a positive number. How many roots are there? 2. They are rational because 1 is a perfect square. Let's first factor it and then we can envision what the roots look like, okay? So I'm looking for the factors of 6 that add up to negative 5. The factors of 6 that add up to negative 5. That's going to be negative 6 and positive 1. Okay. So I have negative 6 and positive 1. Does this add up? Yes, these add up to negative 5x. We're good. So I now have x minus 6, x plus 1 equals 0. So we know that in factored form, the sign's going to flip. So this is going to be my negative 1 root. And this is going to be my positive root. You can always graph these two if you can't envision these, okay? So you're going to keep going with 3, 4, all the way up to 9, okay? You're just going to keep doing the same thing as we did up here.